In this video we're doing A-Level Maths, Edexcel, Pure Maths 1, June 2018, question 9. My name is Sunil Tanna, I'm a tutor and author, my details are shown on the card. I'm available for one-to-one tuitions, both online and in person. For in-person, I live in South Buckinghamshire, England. Let's have a look at the question. Question 9, we're given this diagram here. And it says figure 4 shows a sketch with the curve with this equation, and part A is to calculate the derivative dy dx. Now, in many cases we have an equation where y is already the subject or can easily be made the subject, but in this case it's very difficult to separate out x's and y's, so we have to use implicit differentiation. So let's get started for part A. Differentiating 2xy becomes 2x. Differentiating minus 2xy will become minus 2y and then minus 2x dy dx. Differentiating plus 3y squared will become plus 6y dy dx, and differentiating 50 will be 0. Now you'll notice the last two terms involve dy dx, so we can factorize those out. So we will have 2xy minus 2y, let's write it the other way around, dy dx times 6y minus 2x is equal to 0. And we can now see how to make dy dx a subject. First of all, bring the first two terms to the other side. So dy dx times 6y minus 2x will be equal to plus 2y minus 2x, and now divide by 6y minus 2x. So dy dx is equal to 2y minus 2x divided by 6y minus 2x. And hopefully you'll notice there that in this fraction everything on the top divides by 2, everything on the bottom divides by 2, so we can simplify the fraction to be y minus x over 3y minus x, which of course is the answer that we were looking for. Okay, part B of the question. I've got another copy of the question so we won't have to flip between pages. Part B is to find the exact coordinates of point P. Now if you look at the diagram, you'll notice at points P and point Q the curve becomes vertical. In other words, the gradient approaches infinity, or becomes infinity for that point, you can think of it as being, which in other words means the bottom of the derivative fraction, so 3y minus x, will be equal to 0. So for part B, the first thing we notice is at P and Q, 3y minus x is equal to 0. So rearranging that, we'll see that 3y is equal to x. We can now substitute that into the equation for the curve and then solve that as simultaneous equations to find out x and y's. So substituting for x squared is the same as 3y squared. Minus 2x times y will be the same as minus 2 3y times y, and plus 3y squared will still be plus 3y squared, and that will still equal 50. Now if you look at the terms on the left hand side, the first one is 3y all squared, which is the same as 9y squared. So we write that out. The next one is minus 6y squared, and the last one is still 3y squared, and that's, if we simplify that, that gives us 6y squared is equal to 50. Of course, we can divide both sides of 6y squared and 50 by 2. So 3y squared will be equal to 25. Divide by 3, y squared will be equal to 25 over 3, and then square rooting, y will be plus or minus the square root of 25 over 3, which we could think of as being plus or minus, square root of 25 is 5 over root 3, and of course we can rationalize the denominator. So if we multiply top and bottom by root 3, we will end up with y is equal to plus or minus 5 root 3 over 3. Now the other thing that we notice is we can find the x-coordinate, because we'll notice that x is 3 times y, which we had in the very first line here. So the corresponding x will be x is equal to plus or minus 5 root 3. Now, if you look at where p is, both the x and y coordinates are negative, so they're the negative pair. So p will be minus 5 root 3 and minus 5 over 3 times root 3. Let's make that minus a bit clearer. And that's part A of the question completed. Now look at part B of the question. I've got another copy, so we can still look at the question without flipping pages. Part C of the question, sorry, part B we've done. So for part C, it says, explain how you would find the coordinates of the point that is furthest north of the point of the origin O. So if you look at that, that's the point where the curve becomes flat at the top. There is another point on the curve where the curve becomes flat, which is the furthest south point, which is also the gradient is 0 at both of those. So the gradient is flat or 0 at both points. So for part C, we'll say that the furthest north and south points dy dx is equal to 0, which tells us that the top of the fraction y minus x is equal to 0, or which tells us, if you want, x is equal to y. And now we can again substitute that then to the original equation. So we would then substitute it into x squared minus 2xy plus 3y squared equals 50. And we would solve that. Solve as simultaneous equation. Remember, it's asking us how to do it, not to actually do it. Now that will give us two solutions, which will give us a positive x and y corresponding to the furthest north point, and a negative x and y, the furthest south point. So we can say here positive x and y solution is furthest north. I'm going to put in brackets here. Negative x and y solution is furthest south. And that's it.